I don't know how to start this, so this here end-of-year project asks me to share some of the things I've learned over the year. And while I wasn't here for the whole thing, I did learn some things in my half year of being here. And this project asks me to go over one specific unit, I think, and go over 15 different little definitions in there. Yeah, why don't I just split that up into 3? This is much better. Most of my definitions will be grid-related, because grids are pretty important in geometry. What is a grid? We'll get to that. Anyways, my definitions will fall under 3 categories: the basics of grids, the utility of shapes, and miscellaneous. So I'm not going to count this as one of my definitions, but let's get started with the basics of grids. Now this is a grid. I'm a grid. Yes, you're a grid. Thank you very much. I'm a pattern of squares upon 2 axes. And that is our first definition. Axis. An axis is a line to act as an anchor point for transformations upon a grid. Transformation is our next definition. No, it is not. Our next 2 definitions are point and origin point. A point is a visible spot on the grid, usually mapped by a letter, to use as a reference point for other things, such as little edges of triangles and whatnot. This is getting highly unprofessional. Now, the origin is a normal point, but it's special, as it denotes the 0, 0 coordinate. The origin point is the center of the grid, and it's also where the x-axis and the y-axis meet. Oh, hey, the origin point is on my nose. You don't have a nose. Our last few definitions have to do with lines. Okay, the last few definitions for part 1. Now, a line is, well, you know what a line looks like. But in mathematical grid terms, it's an infinite straight line following a slope formula, which is sometimes simplified to show the measurement of shapes and whatnot. A ray is like a line, but it actually has a starting point. However, there is no endpoint. It is another infinite straight line. And that's it for the basics of grids. Now we're on to the utility of shapes. This is also the part where we can finally talk about transformations and the 4 types. Yeah, that's kind of the whole thing with the utility of shapes. A transformation is any sort of change made to a shape, whether it be shape, size, rotation, let's go through those. Translation, often denoted through changes in x or y coordinate. It's the main form of movement for a shape on a grid. Rotation. It's also a way to move a shape, but it has more to it. You're going to need a point to anchor for this one, usually the origin. A rotation will change the x and y, as well as the direction the shape is facing. Now, a dilation messes with the shape, and it also changes the x and y coordinates. Dilations are recorded on a base 1 system, with 1 being no change at all. If it's dilated by 2, it gets 2 times bigger. If it's dilated by 0.5, it gets 2 times smaller. Now finally, reflections. These are transformations done upon axis, x and y. And, say it with me, this is lame. But yeah, reflection makes the axis that it is being reflected upon act as a sort of mirror, and the shape will be, mirrored, like that. And lastly, we have miscellaneous. These are just a few extra definitions I wanted to squeeze in here. Now we're going to take a bit of a detour to circles here. A circle's diameter, that's the length of a circle from end to end. A circle's radius, that's half the circle's diameter. How about something applicable to all shapes, like area, which is how many squares on a grid that a shape takes up. And, I don't have any more definitions. I guess the project's done. There's no good way to do math problems in a video, so I'm just gonna